Hi, welcome back to ICE. In this video, we are going to look at how to represent web designs. So remember that a web design comprises the structure of the website, which includes the relationships between pages. And a page may also contain a form, a web form that contains sophisticated user interaction and form widgets. So the SNN is used to represent the structure of a website, that is the relationship between pages. Whereas the IFIN diagram is used to represent the interaction or what happens within a page. So not all pages will require an IFIN diagram, but pages which has sophisticated user interaction, like a complex form, for instance, can be modeled using an IFIN diagram. So what is WNAM? Right? WNAM is actually a notation for representing two types of diagrams. The site navigation net, which represents inter-page relationships, and in-context flow of interaction diagram, which represents what happens on a single page. Now, there's no standard notation to represent the structure of a website or the interaction on a sophisticated form on a web page. You have something like UML, which is a fairly standard notation for representing object-oriented designs. But for web design, there's no standard notation. But in this subject, we're going to stick to WNAM. So what UML is for object-oriented design, WNAM will be for us the design language for representing web designs. There's a number of things that you can use an IFIN diagram or WNAM to do to represent different steps to carry out a task, to represent our designs so that we know what's missing, and also to allow us to put our design down on paper. Now, the reason that one might want to put the design down on paper is to try and debug the design, if you like, to look at the design, to review the design. So imagine you have a design down on paper and you have your group members sit around the table and try and critique and discuss the design. So it would be very useful to have the design put down on paper, at least a draft of it, and then you keep revising the draft. So you can identify illogical design where the flow of tasks to be carried out doesn't seem to be logical, incorrect design, or incomplete design, for example, when something is missing, right? So when you start writing something down, you can more easily identify illogical, incorrect, or incomplete designs. So illogical design could mean some of these things, right? What's the flow of tasks, right? So what's the logical flow of the tasks, right? One thing to another. For instance, if you wanted to purchase something, if you have bought something from Amazon before, it takes you through a series of steps, a logical series of steps to accomplish a task. So what's the flow of the screens, the pages? How can a user get to what they look for example, in a navigation menu and so on, right? So you might want to look at a website and say, okay, suppose the user want to accomplish this task. How easy is it for the user to do that starting from the home page and so on? So what user actions and system actions can be synchronized, what can happen in parallel and so on. In terms of incorrect design, maybe the flow of tasks is incorrect. Or perhaps there's too much on a page. For instance, you wanted to order and buy something through the website. It may be that there's too much on one page. Perhaps it's too big. So you want to split that over a number of pages instead, for instance. Or there are too many pages, for instance, to where each page is too small. Right? Perhaps you want to combine some of the pages and so on. Incomplete design, perhaps one step in a series of tasks is missing, for instance. So you wanted to have a checkout feature, for instance, but you forgot to show a confirmation message to the user about what has been bought, for instance. So I'm trying to identify missing pages of tasks. And when you document or write your design down on paper, it's easier to do that. So there are two types of diagrams, as already mentioned. The site navigation net shows the interpage relationship, or the links between pages on the website. And the IFIN diagram shows the interaction within the page. So we'll look at both of these. So here you are. On the left hand side is a SNN, which shows the interpage relationships, and each page is represented by that node here, right? So there's a special symbol for node. So it's like a graph or like a tree. And you can see that for each node, there may be a corresponding IFIN diagram. But as I mentioned, not every node need to have an IFIN diagram. A node or a page which has lots of functionality on it might have an IFIN diagram to model the user interaction behavior on the page itself. But if a page is very simple, for example, just displaying something, then there's no need for an IFIN diagram for that page. So each page might have an IFIN diagram, but certainly, while I mentioned here, each page can be enfolded into an IFIN diagram. Something that's so simple, you don't need an IFIN diagram for that page. So on the left-hand side is one node in the SNN, and then on the right-hand side is the IFIN diagram here. So there's a correspondence between the nodes in the SNN and the IFIN diagram. So this is the notation for a node within the SNN, and basically represents one page. And you can think of it as a context, because this is like the current context of the user, if the user is looking at this particular page. So you have the context, or basically corresponding to the page that the user is looking at. And then you have links that correspond to a sequential transition. And these links that correspond to a sequential transition is like a main flow through the website. So for instance, you have a series of pages when you buy something from a website like Amazon. So you're taken through a series of pages, or you order something, you put in an address, you put in your credit card details, you get an order confirmation, and so on. So you are taken through a logical sequence of pages, and that's link here, right? So you're going from a previous page to this page, and from this page to the next page. This logical sequence of pages will correspond to the main flow through these pages. And if you look at the different links on a page, they can be categorized into links which corresponds to the main flow through the page. For example, they corresponds to the next logical step from this page to the next page, right? So these are the main flow links. But there are some links, for example, if you click on something in the menu bar and you jump out to some other subtree, for instance, of the SNN. So these are called jump links. And then there are some links when you click to go back to the previous page. So if you like, these three are categories of links. So these are links that go back to the previous page, or to some page higher up in the tree, some ancestor page if you like. And there are some links which jump off to another subtree, and there are some links which corresponds to the main flow through this website. So you can think of these three symbols here as three different categories of links on a page. So links that corresponds to the main flow of that this page lies in. You have links that go back to a previous page in the main flow, or to jump to some other subtree of the SNN. So every page involves some activity from user to the system, right? So the user might need to put in some information on unless all the page does is just to show something to the user. And of course, system to the user, right? The system displays something to the user. And on every page there are preconditions, which is what must be true before the page is shown. Postconditions refers to what must be true before you can leave that page. So if you think, for example, on a page there's a form. So a precondition may be that certain conditions must be fulfilled before you can see this page. For example, you logged in successfully so you can see that page. And there are post conditions. So what must be true before you can leave that page? An example of a post condition might be that you fill in all the fields on the form correctly, and so you can leave that page when you click on continue or submit. And what is data input? Data input is information that goes into the page from a previous page. So for instance, if the previous page is a login page, you enter your username and password, and then when you submit and suppose you log in successfully, you get the welcome page because you logged in successfully. So suppose you see the welcome page and that page says hello Sing, let's say, and Sing is your username. And so the data input to that page would be the username Sing, because Sing is what you typed in from the previous page. So data input is information that's passed in from a previous page to this page. And you have data output. So if you enter some information which is then used in the next page, it is considered data output from this page or from this context. Now, data output is different from the information that is stored on the database on the server side, right? Because not all information stored on the database on the server side is shown on the next page, right? And then there are three types of transitions, right? Sequential transitions corresponding to the main flow, which are single directional, and there are some which are bidirectional links, that means you can go forwards and backwards, and there are some links which are just to go backwards up to a previous page somewhere. So every transition must be clearly marked going from one place to another. And you have so-called non-sequential transitions. That means these links exit the main flow through the page. So for instance, you decided to order something and then you fill in the address and then you fill in your credit card and so on, and then you change your mind. So you click on a jump link so that you can jump out to somewhere else, right? So that's the idea of a jump link, right? The non-sequential links, right? So here's an illustration of a jump link. So you might have a main flow. So for instance, if you decided to order something, you may be taken through a series of pages corresponds to completing a transaction, right? But somewhere in between, maybe you want to find out more information or you change your mind, you can click on the jump link to jump out of the main flow. So that's the main flow, and then you can jump out of it. And that's why these are called jump links, right? It jumps to another subtree, for instance, on the website. And they're also sometimes called non-sequential links. And if this jump link happen to be a navigation bar, for instance, you can represent it this way. So that's the idea of an SNN. You try and represent the main pages of the website. So remember, it's a design notation, right? Do not necessarily represent every single detail, but at least the main pages of the website, the main flows through the website is all represented. And each of these subtree, each of these branch might correspond to a category of user or to a task and subtask that needs to be done, right? Each of these is like a main flow through the page to accomplish some task. And this is another main flow to accomplish another task. So at the top level, you might have your node and then each of the navigation bar options, right? Each item on the navigation menu may go to a separate subtree, right? Okay, so let's look at an IFIN notation and we'll look at other examples of SNN later on. So IFIN borrows the notation from something called Petri nets, which are very similar to state transition diagrams. Right? So if you're familiar with state transition diagrams or STDs in UML, IFIN is basically very similar to that. So you have circles which represent states, and then start and end states, special states are represented using double circles, and then you have a user action, right, which is a horizontal bar, and then the token that represents the progress from one state to another. And you have token firing rules in a sense that you have pre and post conditions, right? So this is a user action. For this user action to be enabled, these two states, which correspond to two conditions, must be satisfied before you can move these pebbles, if you like, or move this dot here from here to there. If there's a dot on these two, it represents that these two preconditions are true. The user performs the action and will result in these three dots forming. So in parallel, if you like, it represents the state after performing, it describes the state after performing this user action. And if you like, these are the post conditions, these are the preconditions. Preconditions that must be true before the user can do the action. After the user does the action, what are the post conditions? Now, this is not to be confused with the pre and post conditions for the SNN, for the context, right? This is what happens within a page, whereas the SNN is what happens between pages. So if you've got a very sophisticated form on a page, so you're looking at a page and you have many different things, many widgets, many different UI components. It's a complicated form. You can model it using an IFIN diagram so that each of the horizontal bars corresponds to some action on the form, correspond to certain fields that need to be filled in, for instance, and then the states corresponds to the progress through the form as the user starts filling in the form. And there's certainly a correspondence, right? So imagine this is the page on the website or a context on the SNN corresponding to the website. And corresponding to that, you have an IFIN diagram, say if there's a complex form on that page or in that context. And so the entry point corresponds to the start state of the IFIN diagram, and there are two exit points from this context. There should be two final states as well. So and if there's a jumbling, there should be a jumbling in the IFIN diagram. So there should be a correspondence between these two. So here's an example, and we're going to consider the SNN for these three pages. Right? So if you look at this entire website, this page corresponds to this node here, this corresponds to this, and this corresponds to this. So this whole thing here, the whole subtree here corresponds to doing a booking, right? So it's a main flow for doing a booking, the main flow of pages. So here's the first step, right? The user enters a whole series of information and clicks submit, or it may click cancel. And this is an IFIN diagram that corresponds to this particular form on a page. So the context is shown, the page is shown, so there's an initial state, and then it selects a warehouse. And you can see here warehouse selection, right? So this corresponds to the first task that the user does to select the warehouse, and this is provided that the warehouse list is enabled. And of course, in this case, the user just clicks on this and selects a warehouse. It's always enabled, right? So imagine there's a token here, and when a context is shown, there's a token here. The user selects a warehouse and then goes to the state where the warehouse has been selected. And then at this point, the user can enter the booking details, and these are the booking details here. Or the user can click at the AT button, and the AT button corresponds to this plus button here. Right, so the user can fill in all this information or click on the plus button to get more explanation, if you like. So there are two things that the user might do. So if the user clicks on that AT button, it jumps off elsewhere, goes to a different branch to view the pages and so on. Or if the user keeps on going by entering the booking details, then the booking details will be filled. And the booking details are all this information: goods arrival date, goods arrival time, goods details, and all that. So all these are grouped together into one user action. which is called enter booking details, as modeled here, enter booking details. So filling up those set of fields has been summarized into enter booking details in this example, right? And once the booking details are filled in, the user can then do this or that. You can hit the cancel button and then go to the top again and start filling in the form again, or the user can click on the submit button and finish, right? So you notice that this is only one way to model that particular page, and there are many ways to do that. So instead of having just one horizontal bar, enter booking details to represent all this filling of all these fields, you might have separate horizontal bars for goods arrival date, goods arrival time, transport company. Each of these might be represented as a separate horizontal bar. So you might go into a bar for entering the goods arrival date, and then another bar for goods arrival time, and so on, right? So you might do that. So you might have something like this. You might go to instead of enter booking details like this, you might go into here where you enter the goods arrival date. And so you might enter the goods arrival date. And so here you might enter the short form goods arrival date, and then you have another bar, right? So this is a state where the goods arrival date has been entered. So GAD entered, and then you can go on to the next action on the form, which is to enter the next field, right? Field, and then the next one, and so on, right? So eventually everything is done, and then you come back to this state, right? So this is an alternative, right? So where every field is represented by a horizontal bar, right? But you can group all this together into one horizontal bar called enter booking details, right? Which is, if you like, simpler. So it's a design notation, so you're free to kind of adapt your design diagram, just like you have UML. You might make some simplifications to model what needs to be modeled. Okay, so this is the next page, and the next page is a very simple RepresentingDesign diagram. There's not much, no complicated form here. You either confirm or cancel. So the page is shown, you either confirm or you cancel. Cancel, it goes somewhere else. If not, you continue. Right? So in fact, a page like this is so simple, you don't even really need an RepresentingDesign diagram. Right? And then there's the third page, which again is very simple. You just show these two. And you notice that the menu bar is found on all the pages, right? So if you notice, this menu bar is found here. On the first page, is found on the second page, and it's also found on the third page. But you might not show it on every page, right? So you might only show it on the last page. So this is the home button, a jump link, which is the home button, which may correspond to clicking on a logo somewhere, for instance. And then this is the navigation bar, which comprises a whole set of things, right? And which corresponds to a whole set of things here. Lot balance, lot movement, order status, so LB1, LM, OS, and so on. Right? So this corresponds to the navigation bar. Okay, so but we'll look at more examples of WNAM and RepresentingDesign in the lectures to come. So enter booking details, cancel button is tested only once. Of course, you can click the cancel button anytime, right? So if you look at this particular form here, even if you have filled in 1, 2, and 3 of these, you can still click on the cancel button, or you fill in 1, 2, 3, 4, 5 of these, and then you click the cancel button. So the cancel button can actually be pressed anytime. But you notice that in the RepresentingDesign diagram, it shows the cancel button only after the warehouse has been selected, after all the booking details have been filled in, then only you can click the cancel button. Right? So there's a simplification here. Otherwise, you would have to put the link to the cancel button everywhere as an option. Right? So for instance, you would need to add this option here, which is to click the cancel button. Right? So you got to have this option here. Right? So after selecting a warehouse, you could continue entering booking details. You could click the cancel button and then go back up, or you could click the AT button. So by right, you should have this everywhere, right? But it becomes too complicated. So you can make a simplification here, and you just model the cancel button at the end. Right. So it's shown only once, although you can click it at any point. So when you say button on an RepresentingDesign diagram, it could be a rail button, HTML button, or it could be a link, or it could be something else. Right? So when you say button, it's just something that you could press to go somewhere else. You want to use the SNN and the IFIN to capture the user navigation between pages as well as user interaction within each page, particularly if there's a complicated form on the page, so that you can debug the form before you actually start coding it.